Let's continue talking about margins of error in partial differentiation. In this case, we have a cylinder with radius 3 plus or minus 0.15 meters, and the height is 5 plus or minus 0.2 meters. Alright? Now we want to find the largest and the smallest volume. The fact is, we have two methods that we can use. You could use the extreme values, that means the highest radius and highest height, as well as lowest radius and lowest height. But we could also use partial differentiation, and partial differentiation will be more accurate than just using the extreme values to calculate the highest and the lowest volume, right? So we see the fact that when you use extreme values, there are some assumptions. It assumes, for example, that both radius and height reach their values at the same time, right? Here, it assumes both the radius and height, they reach their maximum and minimum values simultaneously. And it doesn't consider small errors that add up, or how radius and height interact with each other. Using partial derivatives, though, right, it's more accurate. For one, it approximates the small volume change due to small variations in radius and the height. But let us see what both of them would yield. Here, the extreme values. So, using extreme values. Now, what it says is that the large volume, so at the larger end of the scale, volume would be pi times r squared. You know that the volume is pi r squared h. Alright? Now, the higher volume, the higher radius, would be 3.15. That's 3 plus 0.15 squared times the height. The higher height would be 5.2, which is 5 plus 0.2. Let me calculate that off the air. I have pi times 3.15 squared times height, which is 5.2, equal 162.1. So I have 162.1 meter cube. Now, the small volume, the one at the smaller end of the scale, let's call it VL and VS. Volume small would be pi times, in this case it will be 3 minus 0.15, which is 2.85. So 2.85 squared times, and the smaller height would be 5 minus 0.2, which is 4.8, right? Which is 4.8 equals, so I have pi times 2.85 squared times 4.8. So you have 122.48. 122.48 meter cube. So Here now, what is the nominal value? The nominal volume, right? Let's call it V, NOM, nominal value. Volume, that is neglecting any error, would be pi times r squared is 3 squared times 5, pi r squared a. Pi times 3 squared times 5 would be pi multiplied by 9 multiplied by 5 would be 141.37. That would be 140. Let me write that again. 141.37 meter cube, that would be. So you have 141.37 in the middle. It can go as high as 162.1 or as low as 122.48. all right, so you have a difference of, so 141.37 minus 122.48 would be 141.37 minus 122.48. That's what, 18 point, call it 18.9. And here 162.1 minus 141.37 gives us 20.73. Alright, so that's using extreme values. Now let us use partial differentiation. Now, a small change in v would be the partial derivative of v with respect to r times a small change in r plus partial derivative of v with respect to height times a small change in height. Now, what is partial derivative of volume with respect to r? Well, looking here, it would be 2 pi rh. Let me write the pi a bit clearer. Get rid of this. So it's pi r squared. Okay, it's 2 pi r h for the partial derivative of v with respect to r. So it is 2 pi r h. Now delta r, what's delta r again? The change in r plus or minus 0.15. So delta r is 0.15. Now delta v by delta h would be, when you differentiate this, you get pi r squared. So that's pi r squared. And then delta h is it 0.2? Just want to make sure. Yes, it is 0.2. So the change in v now is equal to 2 pi times radius, and the radius is 3. So 3 times, and the height of 5, right? Height of 5 times 0.15 plus pi times 3 squared times, and the change in height is 0.2. So let's see how this goes. The change in volume would be, let me just calculate this here, 2 times pi times r, which is 3, times height, which is 5, times change in r, which is 0.15, gives us 14.137, 14.137 plus, then we have pi times 3 square root is 9 times 0.2 equal 5.655. So when you add them, that plus 14.137 is equal to 19.79. 19.79. That's a small change. Now, here, up here on one side is 18.9, on the other side is 20.73. Now, what will be the extreme values? Remember, the nominal was 141.37. So we have 141.37 in the middle. Now, if you say the 19.79 plus 141.37, you get 161. Alright, call it 161. And then if you subtract, you get the lower end of 141.37 minus 19.79 equal 121.58. 121. Call it 121.6. Alright, so here, this one is more accurate. Even though the difference might not be considered too much, right? But using the partial derivative is more accurate. And you notice here, the range, you have two different ranges, 18.9 and 20.73, using the extreme values. But here, this has one range, 19.79. It's plus or minus 19.79. Alright? So, this is saying that the volume is 141.37 plus or minus 19.79 meter cube. I said meter here too, the meter cube, cubic meters. Alright, so that's it. I'll see you in the next video.